Okay, on this video, what we're going to be covering is optimization. And this was an activity, should not do this and talk at the same time. This was an activity we did the week of Thanksgiving on, and this particular video is going to cover the thing we did on Monday. Okay, so what they did in class was they first went to this website, which I'm going to pull up here. If you just type this in, you could get to this website. Also, all these links are on my Implied site as well. So if we notice, this whole applet here is about maximizing the volume of a box. Okay, so imagine you had a big sheet of paper, cardboard they say here, and it's 25 inches by 20 inches wide. And what you're going to do is you're going to cut out a square of each corner X deep and fold those flaps up, and you're going to get a box. And so down here is a much better idea of what's going on. And so I'm going to scroll this from left to right, and I think the length and the width is kind of cut off right here. I'm not sure why, but that's the 25 and 20. That is going to kind of stay a constant. And so as we move the slider to the left or to the right, you know, if I move it to the left, notice that the height is really small. It's really short box. Therefore, the volume can't be very big. But as I scroll to the right and make that height bigger and bigger, in other words, I'm cutting into the box more, therefore the box has a bigger height, the volume is getting bigger, but at some point the height becomes so high that the other dimensions are really tiny. Or the base, we could say, is so tiny that the volume can't be really big. And if I think about, okay, what could X be? Well, X could be 0. I could not cut into the box at all, and then that would give me a 0 volume, so that wouldn't be very interesting. And if I move the slider all the way to the right, it says that X could be 10. So I want you to think, though, what about the box, maybe even looking at this picture right here, what about this makes X 10? Well, I noticed that my shorter side is 20 inches, and think about if X is 10 and you're cutting in 10 inches from one side and 10 inches from the other side, you can't cut any more than that. So in fact, X can't even be 10. So let's go ahead and record here what we've talked about so far here. X is the height of the box. And what is the largest possible? It's 10 inches because that's half of the shortest side. And when I say shorter side, I'm talking about the paper that we're even making the box out of. All right, this says read number 2. What is the volume of the box in terms of X? Draw a picture of the net and 3D figure below. Label the dimensions in terms of X. All right, now you're going to notice on this video, I'm not going to do everything that it says because this is the video. If you want to go and look at this website and read through all of these, you definitely can. You're going to get what you need to get out of it just by listening to me, but if you want to really understand this applet and how it works, you might want to go through and read these things carefully. So number 2 is all about finding the volume of the box, okay? And if you were here for the pre-assessment, then you know how we did that. And they go ahead and tell you how to do it in here and too, but I'm going to explain it by looking at the picture. Okay, if we think about the volume of a box, rectangular prism, we're going to have length, width, and height, okay? And let me go ahead and I'm going to explain this more carefully by writing it down here. Okay, so we have the net, and by net I mean that folded out picture of the box and its flaps. Okay, it doesn't have to be pretty or perfect or whatever. All right, and so here we have our box, the 3D picture of the box. Like I said, it doesn't have to be very pretty. All right, now if this original thing here and here were 25 and 20 inches, and I'm cutting in X, so all of these little dimensions are X, all of them. All right, think about what then the length and the width, and you know the height here is X, that's constant, but what would this length be here after you cut out an X and fold those flaps up? That would be 25 minus 2x. In fact, whatever this number was, minus 2x. So what would be the other one? okay? It would be 20 minus 2x. So the volume of the box in terms of x, okay, would be x, and then it doesn't matter which one you put first or second or whatever. All right, and so if you were thinking, hey, isn't it just base, or base probably isn't very good, length times width times height, if you were thinking this, yeah, that's great, but that's in 3 different variables. We have to have the volume in terms of one variable if we're going to do calculus on it. And so this is the volume. Now you could multiply all this out. That would make the next step easier, but we're going to leave it like this for now. Okay, so this next part says explore the slider. What value of x gives you the max volume? Okay, so we're going to first do this by looking at this picture. And exploring the slider, and then we're going to do this with calculus. And so we could be looking at the actual volume of a box, but you know what I'm going to do is I'm going to notice, hey, the volume of the box is this maximum. This is what optimization is about. And so if I look down here, this is the derivative. Now, what is the derivative at a maximum? It should be 0. Look at that line right there. That's a horizontal line. The slope of that line is 0. And so there's a couple of different ways we could think about this. And so it looks like we have about 3.67 and about 820. And that's as good as we can get, and it's actually really close. All right. We'll see here in a minute. 3.67 inches. And then the max volume would be about 820 cubic inches. Now, we really should be doing these little abouts because, you know, if we go back to the slider and I move something just slightly, it still seems, you know, it's really hard to tell exactly where we have, because I don't have where the derivative is equal to exactly 0. I only have estimates. Okay, so this is where calculus comes into play, and you know you won't always be given an applet. If I change the 25 and the 20, this applet doesn't really help you unless you figured out that you can change the numbers down here. But anyway, and so what we need to do is, taking a cue from this applet, we need to take the derivative of our volume formula, set that derivative equal to 0, in other words, find the critical points, and assess what the maximum is. This is what we did all in Chapter 3. And they're going to lead you through that. If you really read through 3 and 4 here, they're going to lead you through that. Okay, so I'm going to go back, oops, this page. And I go back here, and finding v prime of x. Okay, so we have a couple of options. I can multiply out all of v and do that by hand, and set it equal to 0, and do that by hand, do all of that by hand. Okay, great. That was all Chapter 3. You proved you could do this. What we're going to do is we're going to use the calculator. These are word problems, so you're pretty much going to get a calculator all the time. And so I'm going to actually pause the video while I get back. Okay, so if you don't have your calculator ready, pause and you get your calculator ready. All right, so the first thing I'm going to do is make sure that I'm cleared and my variables are cleared. So if you remember, F1 will clear the home, and then also second F1 gives you the option of clearing A to Z. Now, you may not want to do this if you have lots of stuff stored, but you don't want to be typing in X here and there be a number in for X. I want X to be truly X. Okay, so remember to differentiate. We're going to do F3, differentiate. Then I'm just going to start typing in the formula. This is why it was really important that we do this all in terms of X, because we don't know how to do this when it's multivariable. I'm not saying that's impossible. It's definitely possible, but it's outside of where we're at right now. All right, so I've typed in the expression, then I'm going to do comma x in parentheses. So, oops, my comma didn't go through. Let me hit that harder. There we go. Now I'm going to press enter, and it's going to give me this error because we haven't, and I kind of purposely did this so that, because we haven't really done this. So I'm going to press escape. It says invalid implied multiply. So let's think about what that means. It means that your calculator does not know that what I want to do here is multiply. So I just need to put the multiply sign in. Okay, we should probably have put it in here. We hadn't seen that yet before, so I wanted to make a point of it in this video. All right, and so here we have the derivative. And this makes sense because Oops, sorry, let me bring that back. This makes sense because if I had multiplied x, this whole thing out, it would have been a cubic. And when we take derivative of a cubic, we get a quadratic. And so I'm going to go ahead and write that here. So v prime of x equals 12x squared minus 180x plus 500. Okay, so now we got to think, okay, that's check. Now we got to do critical points. Let's do this one. That's where you set this equal to 0 and you try to figure out, okay, what is x equal? Let's go back to our calculator again and let's not do this the hard way. Okay, so I'm going to clear this out and I'm going to go, we could do 0, we could do solve. Y'all seem to be a lot better with the whole solve thing. So I'm going to hit solve, enter. And I'm not going to retype this. I'm going to go pull that down here by just going up there, pressing enter. It pastes it right here. I have to put the other side of the equal sign. You can't solve an equation without the equal 0. Your calculator cannot read your mind. You have to tell it what to do. And then always comma x. Then you end your parenthesis. Okay, and we are going to get two different answers, and they're both exact answers. So this tells me that this thing did not factor. If we had done this by hand, we would have had to use quadratic formula. So I'm going to hit diamond, if I do it, diamond, enter, to approximate, and I get these two answers. Okay, so 11.319, and we also get x equals 3, and if you can't read it, go up there, hit the right area, 3.681, because we want to be accurate to 3 decimal places. And so we notice that one of these is really close to what we had right here, okay? But I also have this 11.319. It's giving me two answers because there's two true solutions, but we said that the most x could be was 10. So can x be 11? No. This is kind of like one of those extraneous solutions. All right, now so far I've found x, but I really don't know for sure algebraically and using calculus. I don't know that this is a maximum. We know that the derivative could equal 0 for a minimum or for those weird points of inflection, okay? And so we need to confirm this, and it's very easy to do, okay? It's just gonna be like what we did before. In chapter 3. And so I'm going to plug in a number like 0, and if I were to plug in 0, I would get a positive, right? It would actually end up being 500. And if I plugged in something larger than 3.681, and I'm going to go way large, I'm going to think like a billion. If I were to plug in a billion, this first term, like what do you think? I mean, we know that normally it's plus minus, but you could, you know, we got the 12x squared, okay, but we've also got this 180x minus thing going on. Okay, either way, I'm not going to spend too much time on this. You have a minus. So what ends up happening was our volume was increasing, and then after 3.681, our volume was decreasing. We've confirmed that this is in fact a max. All right, that's what I mean by sign chart. And so our final answer, we could say, is something like the max volume is, okay, now I still actually don't know this. I'm going to leave it blank. All right, and we're going to find it on the calculator when x is, you know, about 3.681. This is our best answer rounded to 3 decimal places. Okay, now to actually find this, I'm going to go back to my calculator again. And this is where, okay, let me come down here. Let me clear this out. This is where we don't want to round. All right, so I'm gonna show you some calculator things here. I'm gonna isolate this number here. Probably an easier way to do this, but I'm gonna get that number and I'm gonna go on the other side of it, and now I'm gonna store this in for x. So I'm gonna store in for x. So now every time I type x, you could pick another letter if you wanted to. Okay, it doesn't really matter which letter. It's always going to be this number, so I don't have to type all that out. All right, obviously you could just type it out. That would be fine, but don't just type out the first 3 because we're using this. All right, and I also don't really want to type in the whole equation from the very beginning. So I'm going to come down here, come up there. I'm going to get that now. Remember, I'm not really wanting to take the volume at this point, or take the derivative, so I'm going to delete that. So here's just the expression for volume with x, but remember I have something stored in for x. When I type enter, I should get a number, and remember my number should be about 820, and it is. That's how you can kind of check what you did. So it's 820.528. And that's how you do this while staying as accurate as you possibly can be. Definitely these two numbers are accurate to 3 decimal places. I didn't round until the very end on either one of these. All right, so was this close to my approximation before? Oops. Yes, it was. It was very, very close. Okay, but again, the applet was here to help you know that your answer was close. That's not always going to be given to you. All right, and so what we did in class was we did a second example where I gave them basically the dimensions of the sheet of paper. Okay, I'm not going to go through this in this video. If you would like to do this just to make sure you're able to do it on your own. Come back and see me and check your answer with me. You could also change the dimensions on the applet as well. You could change this length and this width to 8.5 and 11. Do you know your approximation? That would also help you figure out your answer as well. Okay. Well, that's the end of this video.